Hey guys, so I just prepared a quick revision video on what we had covered before the Christmas period. So what you'll see here is we have all of the learning outcomes. I have a video just put up there on the equation of a circle with centre 0, 0 and radius of length r, and I have another video up there as well on the equation of a circle with centre hk and radius of length r. So if you want to have a quick look over them if you were absent or you need to just revise the skill. Okay, so starting on the equations of the form x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And again, these are in your formula and log tables on page 19. So what we know is that the centre here in this equation is minus g minus f. So we're going to be focusing on the g, the f here. And then the radius is g squared plus f squared minus c. So just important to note as well that there cannot be an xy term, otherwise we can't look at it as a second degree equation representing a circle. So when we look here at an example, so x squared plus y squared minus 4x minus 6y minus 12 is equal to 0. What we can see here, when we compare the two equations, so this being the one from our log tables and this being our question, we can see very clearly here that 2g is equal to minus 4x and plus 2f is equal to minus 6. We can also see that our c in this equation is equal to minus 12. So with that knowledge, 2g is equal to minus 4, g is equal to minus 2, and 2f is equal to minus 6, so f is equal to minus 3. So our centre point minus g minus f is actually 2, 3, because again when we apply minuses to both of these, minus by minus gives us plus. And then when we square out to find our radius, so we have minus 2 squared plus minus 3 squared minus minus 12, we get square root 25, which is equal to 5. Here are some questions that you may want to try. We did them in class. This last one, what you will have to do is you'll have to divide everything by 9 in order to get the equation x squared plus y squared, so that you get the correct value for your 2gf or 2gx and your 2fy. So now let us take a question where we have a circle that we're given the centre and we're given the radius length, and we have to find the equation in this form. Okay, so if we look at a question like this, we have two methods that we could use to solve this equation. So the first method is going back to your hk, so a centre point of hk, so where you have x minus h to be squared plus y minus k to be squared equals to r squared. So you could go ahead and pop in your centre point. So what we know then is that our centre will be x minus 4 to be squared plus y. Now just be careful here, because we have a minus 2, then k is equal to minus 2. So minus k is going to be equal to plus 2 to be squared, and that's going to be equal to 5 squared. Okay, so go ahead and square that out. So what we get then is x squared minus 8x plus 16. We have plus y squared. We have plus 4y plus 4, and that's going to be equal to 25. And then just rearranging those, we get x squared. We have plus y squared, so I'm just rearranging it to the format of the equation up the very top there. And then we have minus 8x plus 4y. And then we have a plus 4 and a plus 16, so that's going to give me plus 20. And I bring over the 25 becomes minus 25. So that's going to give me minus 5 is equal to 0. And that's that written in that form. The second method we could use here is that we can clearly see that, or from our knowledge of that form of the equation of the circle, that minus g minus f is our centre point. So in our case, our minus g minus f, we have minus g is equal to 4, and that would tell me then that g is equal to minus 4, And similarly, minus f is equal to minus 2, so f must be equal to 2. So now we have our g and our f. Now we need to find out our c. And if you remember that our radius from the previous slide, radius in this case is equal to the square root of g squared plus f squared minus c. Now we already know our radius, so, and we know our g and our f now as well. So what we can do is we can say that 5 is equal to g squared, which is going to be minus 4 to be squared, plus 2 to be squared, minus c. Now if I just square both sides, I'm going to be able to solve that. So 4 squared is 16, 2 squared. So I've squared that side as well, so that gets rid of the root sign. So I get 16 plus 4 minus c. And then what I'll get is c is equal to 16 plus 4 is 20. Bring that over the far side, I get c is equal to 5. So now if I just go ahead and I fill that into my equation, so I have x squared plus y squared. Now my 2g, well I found that g is minus 4, so 2 by minus 4 gives me minus 8x. And then I have 2f, so 2 by 2 gives me 4y. And then I have my minus, I have a little mistake there, so I had minus c is equal to positive 5, so c must be equal to minus 5. That's what happens when you skip steps, so minus 5 equals 0. I know I did 1 or 2 more examples on these in the notes before Christmas, so please check in with one of your classmates on this. Okay, so points inside, outside are on a circle. So again, just going to quickly run through this. If a point is inside the circle, you'll see that the value of this will be less than the radius squared. Similarly, if a point is outside the circle, the value of this will be greater than the radius squared. And if it's on the circle, that is on the circumference, then it's going to be equal to the radius. So I've given you 2 points here. Find out if they're outside, inside, or on the following circle. So you're given the circle here. So all it is substitutions. When you're trying to find out the points inside, outside, or on circle, the skill here is substitution. So you're just going to substitute it into the equation. So anywhere you have an x and y, you're going to replace x with 7. And anywhere you have y, you're going to replace it minus 5. And what we see is this point is on the circle, the point 7 minus 5. When we look at the point 8 minus 6, again, x and y, we can see that that point, what we get, the value on the left-hand side of the equation, is greater than the value on the right, which is the radius squared. So that tells me that it is outside of the circle. Similarly, we can use the equation that we were just looking at in this form. And again, just by substitution. Now you may be given a center point, or you may be given a point, and what you'll have to do is you'll have to use that point to see if it will fit into this equation. Again, it'll be substitution. You'll have to be given the equation to actually be able to do so. So again, just something we covered before the Christmas break. Intersections of a line and a circle. So when we are looking for when we know that the line intersects the circle at 2 points, you're going to find that the radius length is less than, or is greater than, the perpendicular distance from the center to the actual line that we're looking at. So solving between the line and the circle will give the 2 points. What I mean there is, you'll remember it's simultaneous equations. One linear, one non-linear. So that's the skill. If you can look at that, for any of these actually, if you look at those, you'll be able to see if it has 2 points of intersection, you'll know. If it has 1 point of intersection, you'll know, because when you go to solve that, you'll only get 1 point. And if you can't solve, there'll be no points of intersection. So that's one other way that we could look at this, simultaneous equations of a line, one linear, one non-linear, if we are looking at perpendicular distance, so that formula again for perpendicular distance is in your log tables, and you need to know how to apply that formula. So you could look at if you're given the radius length, and then you have the line, or you have the center, or maybe you're going to find the center, you're going to find the radius, and then you're going to find the perpendicular distance from the center to the line. That'll tell you whether if the radius is greater than the perpendicular distance, there's going to be 2 points of intersection. If it's equal to the perpendicular distance from the center to the line, then it's there's only 1 point of intersection, so it's a tangent essentially. And again, solving between the line and the circle gives 1 point. That's using simultaneous equations. Finally, no points of intersection means that the radius length is going to be less than the perpendicular distance from the center to the line. So I'm just going to quickly go through this question. Show the line L, 5x minus y minus 20 is equal to 0. Does not intersect this line here. So if it does not intersect, this circle here. So if it does not intersect, then we know that the radius length is going to be greater than the perpendicular distance from the center to the circle, to the line. So this is our circle. I want to find the center. Remember, I can just simply let my in this case, if we look at my x squared, so go back to my formula, x squared plus y squared plus 2gx plus 2fy, apology about the x's, minus plus c equals 0. Then what you're going to find is I have here that 2g is equal to minus 2. So g must be equal to minus 1. And similarly, 2f is equal to minus 2. Yeah. So f must be equal to minus 1. Now remember, my center point is minus g minus f. So minus 1 and minus 1, which gives me 1, 1. And then using my radius here, I am substituting that in. I know my minus c is going to be 2, so c is equal to 2, so that's going to be c is equal to minus 2, so then that's going to be minus 2, which gives me a plus 2. So I have 1 squared plus 1 squared plus 2 is going to be 4, and that's root 4 is 2. Same perpendicular distance from the center, 1, 1 to this line. So again, using that formula, it's it's in your log tables. The formula itself, just write it in here, looks like so. So it is the absolute value of ax plus by plus c all over the square root of a squared plus b squared. So in this case, you can see that my a in my equation is 5. My x is going to be 1. And then I have minus 1 instead of my b. And then I have 1 for my y. And then similarly here for plus c, I have minus 20. So that's going to go in there. And then oh yeah, so that was the small mistake that we had seen in the notes previously, that there should be minus 20. It shouldn't make much of a difference because we have those absolute value signs. So what you're going to get is 5 plus 5 minus 1, which gives me 4. 4 minus 20 gives me minus 16, but because of absolute value we get plus 16. And then the square root of 5 squared plus minus 1 to be squared. And then what we get then at the very end is we get this is approximately 3.4. Now, we had already found that the radius, when we looked for the radius is 2. So we can see that the radius length is actually less than the distance from the center to the line, so that line does not intersect the circle.